Well, I think we'll make a start. Can I just confirm that everyone can hear me well enough?
Yep, we can hear you.
Beautiful, thank you. So, well, I think it's probably now the case that nearly every student in the class is in lockdown somewhere in Australia or in other countries. So, for at least the next 2 or 3 weeks, we'll be running the lectures as Zoom only. The ANU campus is essentially closed, and I suspect that may go on for a bit longer. I just wanted to say at the outset, if this is a good time to sort of think about how things are going for you in your study this semester, and to reach out if things are becoming too tough, or you feel things are piling up on you, or you're falling behind, because there's various things we can do to help and support students. Now, let's. What else did I wanted to say? Oh, the I haven't started marking the tests yet, but that will be a job that I'll start in earnest tomorrow night, and I'll try to do them as quickly as I can. As I mentioned in the first lecture, I am by nature a rather slow marker, so my New Year's resolution this year was to try and get faster at it. So I'll do my best to get results back to you as quickly as I can. I will also do a video this week where I go through the questions and the answers, what I was looking for with the questions, so you can have a look at that and get some feedback on how you went. Now, today, the material I want to cover today is pretty much all exploratory data analysis. The good news, I suppose, is that by the end of today, we will have pretty much, I hope, wrapped up the exploratory part of that, and we can start to move on to other things. There will be other data analysis material in the course, certainly, but I do want to move on to some other things. For the tutorials tomorrow, there's no reading, there's no article. I want to do two things tomorrow if I have time. One is I want to do some kind of an exercise to introduce one of the key ideas in the analytic hierarchy process, and then the other thing is work through some examples of doing searches on Web of Science. I have put a video about the analytic hierarchy process in the Week 4 folder on Wattle, but it's kind of optional. I mean, if you have time and the interest, have a look at it. But I'll be explaining the ideas myself over the next week or two. All right, let's get the screen up. Okay, so I wanted to, the next thing I wanted to do is just a couple of the last things that we do with single variables in exploratory data analysis, and then move on to what we do when we look at the relationship between two variables. So what I want to start with is a simple version of what we call a run chart. And a run chart is I mean, when you look at it, it'll be totally familiar to you. It's a line chart of a time series, but it has an additional feature used to identify outliers. And then there is a more sophisticated version that we'll look at later in the course, which has some other features to it. So what we're interested here is, with run charts, what we're interested in is time series data. The example we're going to look at is the start of this third delta wave in Sydney. And what we're interested in is, at what point can we identify a significant change or a process moving out of a stable state, or what we call a state of statistical control. Now, I found from teaching this over the last 18 months that COVID outbreaks they're a good example that people can relate to, but I want to make it very clear that I am not a doctor. I'm not a medical expert of any kind, and I wouldn't want you to be drawing any kind of medical conclusions from what I tell you. Having said that, what I know about the most modern approaches to run charts has come from medical journals, and I'll talk about that later in the course. Now, the data that we're working here comes from the New South Wales government. So like many governments around the world these days, the New South Wales government makes quite a lot of data available to the public, and in many cases you can download it directly from a website. Sometimes you have to pay for it, sometimes you have to register it, but in this particular case the data is freely available to anyone. You just go to a particular web link and the data is yours. I've put there an abbreviation of the link. It's a very long link if I just posted it there, but if you're interested in downloading it and having a play with it, it's there. It gets updated. At the moment it seems to be running behind by a day or two. Sometimes it's actually quite up to date. Now, the data comes in a format that is called JSON, and I don't intend in this course to have you learn anything much about data formats, but I want to use this to make a more general point. JSON is a very common format that's used these days by computer programmers for storing and transferring data in and between computer programs. This image here is what the data that we're going to be looking at looks like in its JSON format, and I have to say that's a particularly neat example. What actually happens is, if JSON can get very messy, okay, so what you have there is two cases. You have the notification date, the postcode, the likely source, a few other bits of information, and that's all enclosed in curly brackets, and then there's a comma, and then you've got the next lot, and so on, and there's hundreds and hundreds and hundreds of them. What happens with a format like JSON is it doesn't have very many restrictions on what you can do. It's a very flexible format, and so what happens is, if you have a bunch of computer programmers building some kind of data-driven website, for example, if they are not well coordinated and careful and thinking about what they're doing and documenting it properly, you can end up with JSON files which are a really complicated mess. And it may work okay so long as the programmers can keep track of it and know what everything does and where it is, but I can speak from bitter personal experience from the data science, data analysis perspective. You can find yourselves given one of these JSON files, and then you spend sometimes several weeks trying to reverse engineer what's going on inside it and figuring out what things mean and getting it into some kind of a format that you can actually work with. The other extreme with data storage is what are called relational databases, and essentially they impose a whole lot of rules about what can go into them and what it looks like. Basically everything has to be tidy tables, and they all have to be linked together in a systematic way, and it's beautiful from a data analysis point of view, but it puts a lot of constraints on the programmers, and these days, particularly in situations where systems are being developed rapidly and changing all the time, relational databases can create too many constraints, basically. So the takeaway there is, if you find yourself involved in a situation where you are commissioning some kind of computer-based system, or working on it, and you know that data will be needed for analysis, you should at least give some thought to having built into the system a way of getting the data out so that it is actually easy to use for analysis and it can be extracted quickly. That's really the takeaway. But in this particular case, everything's pretty sweet. The New South Wales government's programmers or whoever have done a nice, neat job of it, and it was a completely painless process getting the data out. So what you have is you have this table here with columns, and the key thing that we're interested in is the number of new cases per day. So that's a statistic that everyone is tracking with great anticipation and trepidation every day in New South Wales, and we in Canberra are tracking our own numbers, and so are people in Victoria, and I'm sure people in China are doing the same thing. So we have to actually, although this data is in tidy format, so every row in this case is a notification of an infected person. That's what each row is. So it's lovely tidy data. I've put in an ID field. There wasn't one in the original data. So that's fine, but we actually want to reshape the data, what we call tabulate it. So for what we want to do is have a row for every date. So at the moment we have multiple rows. I'm not sure how well you can see that, but at the moment there we have say multiple rows there for the 17th of March. Each one of those is a person, relates to a person, and what we want to do is have a single row for each date and then a number which is the count of people who were identified as new cases. Okay, so this is what our target is, to get data that looks like that. So we have there a series of dates and then the number of new cases on each date. So the 28th of July 2021 there were 260 new case notifications. The New South Wales government, to their credit, have stored their dates in what is known as ISO 8601 format. That's this 2021-07-28, so year, month, day format. This is the standard format in at least some countries. I know in China, pretty much everyone I know there writes their dates in some format like that. But in countries like Australia and the United States, we tend to use formats like this, which are ambiguous. They tend to be the default in the English language version of Excel, and they can create some problems. So the advice I always give people is, look, if you're putting data into a spreadsheet and there are dates, reformat the cells in Excel. I'll show you how to do this a little later today. Reformat the cells to put them into ISO format. And one advantage of that is you can be sure that it will sort correctly if you need to sort it. All right, so that's sort of data details. Now, remember I said in exploratory data analysis we're looking for things like missing data and outliers and so on. Well, we actually have some missing data here. The missing data is not case notifications. We can assume that the data that the government is from New South Wales is providing is complete. It has every case notification. What's missing is that there are some days where there were no new cases. And so those days are just left out of the data set. So we have to put them back in with a 0. So if you look down here, you will see that the 20th of March 2021 is missing. And it's missing because there wasn't a new case on that day. So we need to add those back in. All right, any questions so far? All right. So this is just really basic tidying up stuff. And, this is a really easy case because essentially the people that developed this system for the New South Wales government knew that there were going to be lots of customers for the data, if you like, not just general members of the public like me, but people who are medical experts, who are research scientists, hospitals and so on. Lots of people use this data, so they took quite a lot of care to make it very, basically to pre-clean it.
Sorry, Ed, I just have a quick question.
Yep.
So let's say if 20th of May was included in the table and it said 0 cases on the right column, would that still make the table tidy or not?
Sorry, I didn't quite catch the first bit of that question.
So if the 20th of May is included in that table,
Yep.
Would the table still be considered tidy or not?
Oh, yes.
Okay.
So it would be adding a row, but the row, remember each row is now a date, not a person. So each row contains data from a number of people. So by putting in the 20th of May, we're not duplicating a row, we're just adding a row that's not there. And it just happens to have a value of 0.
Right. Okay. Thank you.
Yeah. If we didn't do that, basically we'd have gaps in our time series. We're doing that because this is time series data. That's essentially what's happening there. Okay, so that's what it looks like when we've fixed it. So you can see I've just put the extra 20th of May date in there.